Hi everyone. In this video, now I'm going to describe some little knowledge about the concept about the tensor. Exactly what are the tensor and the definition or the actual meaning of the tensor in the field of physics and as well as in mathematics. How can we define and how can we understand? I'm going to clarify. And in the given diagram or in given picture, we can see there are three different kind of the like bar diagram. Okay, the first has one like a vertical column. There consists of some cell on that. Okay, this is only one vertical column and it only describes the single component, means only a like vertical component x, like t, c, h, s, o, t. This is the one dimension of tensor, and it also consists of n component, but the rank of the such kind of tensor is only one. And why we say? Because we briefly deal only single vertical component. Vertical component is rank 1, and there consists of this horizontal like T letter, O letter, S letter, N letter, C letter, and this letter is known as the component. Similarly, if we describe some like physical phenomena or the mathematical like quantities or physical quantities in 2D, in 2 dimension, and it is said to be tensor of dimension 2, which is shown in figure 2nd. Similarly, tensor of the tensor of the dimension 3rd is verified or is explained by the 3rd figure. Exactly, the rank of the tensor quantities such as scalar is 0. Similarly, vector has 1 rank, matrix has 2 rank, and tensor having rank 3 is the combination of 3-dimension quantities in some manner. So hence tensor is of physical quantities, and it is one kind of physical quantities. Here the rank 2 is transformed by some specific manner under the some coordination formulation. Then we get rank 2 as a form of rank 3, means that rank 2 combine to each other, combine to each other by some specific like transformation or by specific formulation, and then we convert the rank 2 in the form of rank 3. But rank 2 and rank 3 are different quantities. It is not the same quantities. Okay, so we can visualize the rank 3 tensor in the given figure. Similarly, generally the scalar component has a rank 0. Rank 0 means scalar has only one component to describe its characteristics, means the scalar characteristics are described by a single term such as like magnitude. So it has no rules to transform their one form to another one. So if there is no any changeable value by transformation, some mathematical rules, by applying some mathematical rule on it, then such kind of the component is known as the scalar quantity, and it has exactly 0 rank. Why the 0 rank? Because if we transform by using some mathematical formula on the scalar component, then there is no change occur finally. So such kind of tensor is known as the 0 rank. If there is no change, then we say there is 0 rank. And vector has a rank 1, because if we transform the vector by using some specific formulation into another coordinate, then we we observe that there is a changeable component, like we find their changeable component. So vector has a rank 1. Similarly, matrix has a rank 2. We can see in the figure 3rd on left hand side, matrix generally matrix represented by, or this block of matrix is formed by three-dimensional object, right? And this three-dimensional object is overlap one another, means vector overlap on to the matrix. Matrix is just like as a bucket, and vector is like quantities inside the bucket. So vector compose, or vector get converted into matrix form, and finally matrix converted after combine the such kind of matrix, then it further converted into three-dimensional tensor. And we have another example by visualize with the simple number. Suppose we have quantities, scalar quantities. Scalar quantities means it is just described by some magnitude. It has the only one described phenomena, which is magnitude, just like as a 1. And if this 1 is represented by in the form of vertical column 1 2 3 or the horizontal column 1 2 3, if this 1 is transformed by using some mathematical tools or some mathematical formula, and if we possible, or if it convert 1 into the form of 1 2 3 or vertical, or 1 2 3 horizontal, means this 1 in vertical and 1 in horizontal, then we say that this 1 is a vector quantities. In the vector, just below the vector, there is represent, or there is written as 1 2 3 in vertical column and 1 2 3 in horizontal column. This represent that this one in the form of vertical or horizontal by using scalar, by using some formula between scalar and vector. If we combine such kind of the vector, or if we compose this vector, and if we applying some rules to convert the vector into next another form with the higher dimension, then such kind of the physical quantity is known as the matrix. We can observe on 3rd point of the given picture. And similarly, if we accumulate the vector this matrix in the form of this n number of matrix in the form of single quantity. N number of matrix means there are different kind of matrix, matrix 1, matrix 2, matrix 3, just like as a figure number 3rd. Then such kind of the matrix are composed in a single term or folded into the single term is known as the tensor. And this is the way to convert the scalar into like scalar quantities by using some mathematical formula, means to convert a tensor. Okay, tensor means generally it is there is one function to convert the vector into matrix and matrix into tensor. So this is the general idea about the tensor. Suppose there is given one function t1, then there is also present the function, some specific function, this 4 dotted point, and this 1 convert into 2 and 2 also convert into 1 by using the function this r1, then we say that such kind of the transformation is known as the tensor. Tensor is just like as a physical quantities, and it transform means tensor transform the physical quantities in a specific manner under their transformation of coordination. But in mathematical form, just like as this function f1, tensor is an algebraic object, means algebraic function that describe the multilinear relationship between the set of algebraic objects, such as like in T1, T2, just below and above, there is so many possible way to connect on one another by using the function R1. Such kind of the relationship, multilinear relationship, is known as tensor. And we can also observe, or we can also facilitate to gain the knowledge, or to know about the tensor by observe this figure also. And this is the simple way to observe the tensors. For example, now I'm going to like listen music by using this my device, as well as simultaneously this device also record my voice, as well as by showing me this graphical representation of the diagram or the picture. This multilinear relationship in a single device is known as the tensor. Exactly, tensor found everywhere in our daily life, just like as our television, like as our cell phone, like as our mobile or laptop. There is also the multilinear task. There is also multilinear function to connect each other. They convert. They means device convert the one formulation or one types of the quantities into another one. I think so. It is a multilinear transformation. Tensor is a multi-dimensional array, just like as a vector. If we observe this vector in R64 n dimension, and matrix also in 64. This single form of the vector is transformed by using some function, and we get the matrix of 8 by 8 their dimension, just like as in second figure. And if we use the other types of the function to fold this matrix as a form of new dimension, just like as a r to the power 4 by 4 by 4, and such kind of the transformation rule, such kind of the function to transform the matrix into the another one is known as the tensor. In tensor is generally folded form of the matrix, and we can also clarify the concept of tensor by observing this one, and this one also, this one, and especially tensor is a more important in the field of physics, because they provide a coin or coin size mathematical framework for formulating and solving the physical problem in the different sector, such as our mechanics, electrodynamics. In mechanics, if we are going to explain the concept about stress, elasticity, fluid mechanics, and moment of inertia, we need to extra version of the mathematical tools, or the extra version of the physics tools, which is our tensor. And in electrodynamics, there are different kinds of the color, or there are different kinds of the wavelength, there are different kinds of the frequency. These all wavelength, frequency, and their time period are described in a single unit term as possible by only the concept under the tensor. So thank you so much, and I will try to explain or try to describe any new terminology which I face in my life. Thank you.